Hi, I'm an old guy and I do maths. And our task today is to find which combination of A and B will not render a unique solution for these two equations, for the set of equations. Now, the stumbling block for many people, and that's based on a completely unscientific survey of a couple of my students, is to figure out what it is you're looking for. And I can answer that very simply. I'll do this on a separate piece of paper so you can see what I'm talking about and it won't get in the way. Two simultaneous equations. Y equals, I don't know, x plus 1. Y equals negative x plus 2. And they're on a Cartesian plane. Pretend there's a Cartesian plane here. That is a unique solution. It is the point at which two lines, in this case, cross. Now, a solution that's not unique would be when two lines sit one on top of the other. So that's an infinite number of solutions. And for where there is no solution, you have parallel lines. So what we're looking for when we come to this is we're looking for one of the combinations for which there isn't a solution. Now, how do we figure out where there isn't a solution? Well, it's easier to answer that. No, it's not, actually. I'll put it this way. Where there isn't a solution, a unique solution, we've got one of two things. We've got parallel lines, or we've got an infinite number of solutions, which is one line on top of the other. Same gradient, same y-intercept. So, let's go to work. I'm going to tear off a piece of paper, so that's the noise you'll hear in the background, and use another pad to do my working on. So here goes. Excuse that noise off camera. Okay, so we'll start at the bottom and we'll do 6x plus 4y, so that's putting 6 into that, equals 10, and the second equation, 18x plus 14y equals 6. Now, what I'm looking for kind of quickly here is to see if I can get anything from the gradients. So, a quick bit of manipulation, 4y equals 10 minus 6x, 14y equals 6 minus 18x. Get rid of the 4, move it over here. So my gradient is 6 on 4x, or 3 on 2x. That's my gradient, which I get from simply, it's negative 2, sorry. I'm back at my old habits of missing negative signs. Over here, the gradient is 18 on 14, negative 18 on 14, it's negative. 18 on 14 is 9 on 7x. These two gradients are negative, that's fine. They're not going to run parallel, they're going to hit each other at some point. So this has a unique solution. Just so that this video doesn't drag, I'm going to try this pair next. So that is 4x plus 4y equals 10. So that's me subbing 4 into there for A. and for B, it's going to be 18x plus 20y equals 6. And I'm just going to do the same thing here quickly. 4y is equal to 10 minus 4x, cancel that, put that there. We've got a gradient of negative x. I think I've done that correctly. I just have to watch that I don't work too quickly. 10 minus 4x, divide through by 4. Yep, okay. So, what have we got? 20y equals 6 minus 18x. Divide through by 20. That is 9 on 10x, and that's negative. The gradients are close, but they are going to close in on each other, and eventually these lines will cross, just as my hands do there in front of the camera. So they have a unique solution. I should say that there is one correct answer here, because this was pulled from a multi-choice exam, something that I sometimes call multi-guess. So I'm going to move on to this one, just for the sake of brevity, and see what we get here. So 2x plus 4y equals 10. 18x plus 36y equals 6. Now this looks promising, because if I look at 2 divided by 4 and 18 divided by 36, I think I'm onto something here. So just let me manipulate this a tiny bit. So 4y equals 10 minus 2x, and we're going to divide that by 4 and get rid of the y, the 4y. 36y equals 6 minus 18x. That's all on 36. Cancel that. So negative 2 on 4 is negative a half. The gradient of this is negative a half. We have gradients that are the same here. These lines are parallel. Well, in fact, they're in that direction, parallel. And so they will not cross. They do not have any solution, let alone a unique solution. So you're welcome to try the other two that I left out. I'm pretty sure that that this and this will either render an infinite number of solutions or a solution. But what were we looking for? A unique solution. Does not render a unique solution. So given the wording of the problem, I think that we can fairly dismiss these. And as I say, when you look at the header for this, you can see that it was pulled from a somewhat antiquated exam that was referred to me, which I'm grateful for. Now, what's the way to succeed at a question like this? Well, I would actually tell my students to try the first couple of answers first, because this question allows something like a minute or 90 seconds for an answer. There's a bit of working involved, so it's likely that the correct answer is in the first 2 or 3 of these. That's just exam tactics. To answer the question, how do you do this properly? The first thing is to realize what it is you're looking for. You're looking for a solution that either gives you, as I showed earlier, parallel lines or one line sitting on top of the other. This one here gives you parallel lines. Anyway, I hope you found this useful and interesting. If you did, please like and subscribe. and I'll see you next time. Bye.